We're going to look at another variation of a distillation experiment, and that is steam distillation. Hopefully you remember a little bit about the theory of simple and fractional distillation, and if not, you can go back and review those videos. But both of those experiments involve separating two liquids based on the differences in boiling point, and we talked about why you would choose simple over fractional. But in both of these cases, we're talking about liquids that are miscible in one another. Steam distillation is used when you would like to isolate a liquid that is not particularly water soluble, and the liquid cannot be distilled at atmospheric conditions because it will oftentimes decompose before it would ever reach the boiling point. So a really common application for this is in the essential oils industry. And this is where you would take some type of plant material most of the time, like seeds or leaves, and use steam distillation as a way of extracting the plant oils. When you place the plant materials into water and begin to heat up the mixture, certain components in these leaves or seeds are going to start to leach out into the water. And one of those would be the oils that are inside of the plant material. The oils themselves are not very volatile. Typically, plant oils have boiling points over 200, sometimes 300 degrees, and so there's not going to be very much of the oil in the vapor phase at any given time. Representing the oil vapor here with just a single yellow dot, and the water vapor or steam with a blue dot. And so the steam is going to far outnumber the oil vapor. But what we would like to happen is that eventually, for the total pressure, vapor pressure here, to add up to 1 atmosphere. And it's probably something like 99% water or steam, and then maybe 1% or less of the oil. But nonetheless, once you hit that 1 atmosphere vapor pressure, then you are actively distilling the mixture. And the steam is going to, you have the boiling water down here, and the steam is going to actually physically push the oil vapors up. And so when you see the condensation forming on the sides, it's going to look cloudy because it's going to be a mixture of water and oil vapors. Of course, what we want to eventually happen is that the steam is able to push the oil up further and further until you get the mixture distilling over. And if you were to collect this on the other side over here, like you did during your distillation, the nice thing is because these two liquids are not miscible, they would separate out into 2 layers like you have seen a couple of times now during your extraction experiments. We're going to use a specialized piece of glassware for this distillation, and that's called a Hickman still. The principle of this still works the same as the stills that you used for fractional or simple distillation, but the setup is just a little different. So the vapors will make their way up the glassware and then start condensing up here, and then when they roll down this glassware, they'll get trapped in the well at this position. We can then take a pipette in through the port on the side and suck up the distillate as it's being formed, and then transport that into a centrifuge tube. Because it's a mixture of oil and water at this point, you should see layers separate out, much like you saw for the spinach experiment in the centrifuge tube, or when you did the acid-base extraction experiment. And you will then perform the rest of the workup that's described in this centrifuge tube.